After spending several days writing out a lot of work to simplify your exponents, you'll be excited to know that there are several rules you can use to make life a lot simpler. Exponent rules part 1. Our first exponent rule is that if you have two terms with the same base, you can add their exponents, a to the n plus m. If you have a term that's raised to an exponent, raised to another exponent, you can multiply their exponents. Finally, if you have a term that is being raised to an exponent with several different variables, or a coefficient, you can distribute that exponent to each piece, equaling a to the n times b to the n. Whenever you are in doubt, though, please write it out. That's a good way to eliminate a lot of mistakes. Let's take a look at how these exponent rules play into these examples. For our first one, note that I have two bases that are both being raised to powers and the bases are the same. Because the bases are the same, I can add their exponents to get x to the 8th. Notice that when I wrote it out, I got the same value. When in doubt, write it out. For the second example, because this is the same base, they're both 2's, I can add their exponents. 2 to the 2 plus 3 would be 2 to the 5th, or 32. Again, when I wrote it out, I got the same value. For this third example, I have a term being raised to a power, and in that case I can multiply the two powers to get x to the 15th. Notice that when I wrote it out, I got the same value. Starts to get a little trickier when I have more than one thing inside the parenthesis. Notice that this 4 applies both to the 3 and to the b squared. So this would be 3 to the 4th, b to the 2 times 4, or 81 b to the 8th. This is the same value that I got when I wrote it out, noticing that it's 3 times 3 times 3 times 3 that gives me that 81. Looking at our negative examples from the other day, we noticed that our first one, again, cannot be simplified any farther, negative 3a cubed. However, the second one that has the negative 3 in parentheses being cubed can be simplified. That negative 3 applies, that power of 3 applies to the negative 3, which would be negative 3 times negative 3 times negative 3, or negative 27. But when in doubt, write it out. Our second one has a negative 3 being squared, which is negative 3 times negative 3, or positive 9. When in doubt, write it out. Our next example has the quantity negative 3a being cubed. That cube has to apply to both the negative 3 and the a. Negative 3, that whole thing cubed, including the negative, and the a being cubed would equal negative 27a cubed. Again, when in doubt, write it out and think through what you're actually doing. Finally, this last one, make sure to bring down the negative. It is not being affected by this squared because it is outside the parenthesis. Only the 3 and the a will be affected. The 3 will be squared and the a will be squared, which would give us a negative 9a squared. Again, the same thing as when we wrote it out. When in doubt, write it out. These exponent rules will save you a lot of time on these large ones. For example, this 4th power will apply to each piece in the parenthesis, x to the 2 times 4, y to the 3 times 4, and this cube will apply both to the 2 and to the x squared. 2 cubed, x to the 6th. Simplifying, we get x to the 8th, y to the 12th, times 2 cubed, x to the 6th. Now it's time to put into practice that first rule that we learned, and that rule said that we can add the exponents if two terms have the same base and they're being multiplied. Well, this term and this term both have the same base of x, and they are being multiplied, so we can add their exponents. That would give us x to the 8 plus 6, or x to the 14th. We only have one y term, and that is our y to the 12th, but we can simplify our coefficient. 2 cubed is 8, and we always write our coefficient in the very front. Notice that that gives us the exact same answer that we had up here. And please note that when in doubt, please write it out to make sure that you use the rules correctly. For our last example, we notice that the squared applies to the -1 and to the x to the 5th and to the y, which would give us a -1 in parentheses squared. Make sure you're squaring the negative. X to the 5 times 2, and y squared. Our second term, the 3 applies both to the 2 and to the x. That would be 2 cubed, x cubed. We can now apply that final rule. Well, let's simplify actually first. That would give us a +1, -1 squared, x to the 10th, y squared. This would be 2 cubed is 8, x cubed. Now we are ready to apply that final rule that says if I have the same base and those terms are being multiplied together, I can in fact add their exponents. So I'm going to do that. X to the 10th times x cubed would be x to the 13th. I still only have one y, so y squared, and then I'm going to multiply their coefficients. So 1 times 8 would give me 8, x cubed, y squared. Again, checking, when in doubt, write it out. I got the exact same thing when I wrote out every piece. 8x cubed, 8x to the 13th, y squared. So you may now use these rules if you have not already been on your assignments, but please remember, when in doubt, write it out.